When solving an equation by completing the square, we take a slightly different approach than we're used to taking when we were solving by factoring or solving with the quadratic formula. When we solve an equation by completing the square, we do not actually set the equation equal to 0. What we want to have is the look that's here. We want any term that involves an x. Now, because these are quadratics, there should be two of them. There should be a square term and a linear term. We want any term involving an x on the left-hand side, and we want any constant terms on the right-hand side. Once that's done, it's on the left-hand side where we go through the process of completing the square. We look at that linear term, which has a coefficient of -6, and we'll say -6 divided by 2 squared, that is equal to 9, and a plus 9 is the factor we will use to complete the square. Now, in the last video we saw, that was the end. We were just practicing completing the square. But we're not allowed to just arbitrarily start adding numbers to an equation. We've long established, way back in your pre-algebra days, that you cannot just add something to one side of an equation. So in order to keep everything in balance, we're also going to add a 9 to the right-hand side of the equation. So this new 9 over here that was used to complete the square is accompanied by this new plus 9 that's used to continue the balancing of the equation. So one of the 9s was brought in to complete the square, the other one was brought in to balance the equation. Our left-hand side is now a square, so we can rewrite it as x minus 3 squared. Our right-hand side has a value of 5. And the entire purpose of completing the square is so that we can now use the square root property to finish the solving. I take the square root of both sides of this equation. On the left-hand side, I'm going to get x minus 3. And on the right-hand side, I'm going to get both positive root 5 and negative root 5. We've long established at this point that we should anticipate two answers to a quadratic equation. When it comes to completing the square, those two answers pop up when you take that final square root. So we add 3 to the right to both sides here, and we get 3 plus root 5 as a solution. And we add 3 over here, and we get 3 minus root 5 as a solution. Both of those solutions, irrational. That tells me that from the jump, if I was to try to write this equation as x squared minus 6x plus 4, its equivalent form set equal to 0, I wasn't going to be able to factor it. These irrational parts will never pop up if I'm attempting to solve an equation using factoring. Factoring should only produce rational solutions. The fact that there were irrational solutions tells me completing the square was an option, and it tells me that the quadratic formula was an option. Here we did completing the square, and we found our two irrational solutions.